Pentec provides leading-edge board and system-level solutions for the most demanding requirements in data acquisition, digital signal processing, and software radio applications through excellence and innovation.
We're going to look inside the 78621, which is a PCI Express software-defined radio board for data acquisition and other applications like radar and communications. The board's available in several different form factors besides the PCI Express, including XMC, Compact PCI, and VPX. The horizontal axis of this graph shows the channel bandwidth of various communications and radar systems. These aren't antenna frequencies, just the bandwidth of the signals. The colored rectangle shows the 3 DDCs in the 6821 covering a bandwidth range from a few kilohertz up to 80 megahertz, spanning most applications in a single powerful IP core. Inside the FPGA, we have 3 identical acquisition engines, each with a multi-bandwidth DDC decimating from 2 to 65,536, along with a hardware power meter and a threshold detector. The A to D data or the DDC data can be gated or triggered and then sent to onboard memory. The metadata generator timestamps and identifies each data block, and each block is sent by a linked list DMA engine out to system memory across the PCIe interface. A 3-channel summation block supports onboard beamforming applications, and an Aurora gigabit serial interface propagates the sum across multiple boards. The D2A waveform playback module fetches data from local memory or system memory using its linked list engine, and it delivers data to the interpolation filter before finally going to the D2A converter. Signal quality is difficult to achieve in a high-density FPGA software radio board with so much digital circuitry like the 78621. Here, we see the spur performance of the Texas Instruments ADC 5485 device spec with a 70 megahertz input signal sampled at 200 megahertz. Now we see the performance of the 6821, and you can see that with advanced shielding, isolation, and filtering, we can maintain this 88 dB spurious-free dynamic range. For transient capture applications, you want to input a hardware trigger, wait a certain number of clock delays, capture a specific number of samples, and then repeat the cycle. Triggered data capture is easy with the A to D linked list controller. In the A to D linked list table, you simply enter the delay from the trigger, the capture length, and the number of repeat cycles. After that link is complete, you can jump to any of 64 different links, each with different parameters. For each capture event, the 78621 appends a metadata header to the data stream containing a timestamp, a channel ID, trigger and link number, and a destination address. Filling this table in simplifies complex data acquisition modes. You don't have to write complex programs or develop custom FPGA code. You can store several different waveforms for playback in system memory or an onboard RAM. By filling out the D2A linked list table, you can create complex playback sequences to the D2A converter. Each link specifies the starting address in memory, the waveform length, the number of repeat cycles, and then the next link to play. These links can be played sequentially with or without triggers to start them. Here we see a synchronous 12-channel A to D converter and 4-channel D2A converter transceiver system using 4 78621s. A 10 megahertz reference clock phase locks the VCXO on the master board at the left. The flat ribbon sync cable distributes clocks, gates, triggers, and sync signals to the other 3 slave boards using a bused multi-drop configuration. For more than 4 boards, we offer the 7893 PCI Express board for 8-board systems and the 9193 1U chassis for systems with up to 15 boards. All Cobalt boards feature health monitoring resources, including 11 onboard temperature sensors for strategic components and 6 onboard voltmeters to make sure the many power supplies are within spec. This simplifies systems diagnostics to verify operation at power up, and alarm set points can generate an interrupt to the CPU during runtime. Many applications can be satisfied with the built-in IP functions where no FPGA IP development is required. But for many applications, the Cobalt module is an ideal platform for custom processing IP development and deployment. Pentec has developed the GateFlow FPGA design kit just for this purpose. Designed to work with the Xilinx ISE design suite, GateFlow supplies all of the built-in functions as IP modules with VHDL source code and test benches. GateFlow creates a user application container where all interface signals to the modules are fully defined and documented. The factory-installed acquisition modules are created in this space. Partitioned in this way, your custom IP can reuse many of the Pentec IP modules or replace some or all of the factory-installed functions as your application requires. Pentec's ReadyFlow board support package provides the software development component to the Cobalt family. Delivered as high-level C-callable libraries, ReadyFlow contains all the routines for board configuration and operation. Available for Windows, Linux, and VxWorks operating systems, ReadyFlow libraries are fully documented with C source code provided. ReadyFlow requires no runtime license, and a single seat can be used for multiple projects. The ReadyFlow BSP includes many applications examples that can be used as tutorials or as the foundation for your application. ReadyFlow also includes pre-compiled examples that can be started through a command line interface. Simply enter the command with parameters for which channels to enable, the number of data sets to acquire, and a destination for the data, and the board will begin operating. Data can be sent to a file, to another application, or to the included ReadyFlow signal analyzer, where it can be displayed and measured both in time and frequency domains. With the command line interface and the signal analyzer, you can be up and running within minutes of opening the box and without writing any code. Pentec's customers use the 78621 for both communications and for radar systems in nearly equal numbers. For advanced military radios, the combination of A to Ds and D to As in the same module, along with the digital up and down converters, make the board a complete IF to IF software radio solution. Built-in data acquisition engines easily capture radar pulses using external hardware triggers to form precise range gates and complex acquisition sequences. Likewise, the D2A waveform generator engine can produce complex IF radar pulses from waveforms stored in memory. Synchronization across multiple boards supports phase-coherent operation across multi-element antenna arrays.
Contact Pentec for price and delivery and for application design ideas.